Okay, we'll get back to section 5.4, and I'm going to try to finish up this section in this video here. So we just want to look at some more examples of solving systems using matrices. So here's another example. Okay, what if we want to solve this system using matrices? Well, the first thing we need is a matrix, right? So I'm just picking off the coefficients in front of the variables, right? Be 1, -1, 1, and 8 for row 1, and then 2, 3, -1, -2 for row 3, or row 2, excuse me. And then for row 3, we have 3, -2, -9, and 9. Okay. The first thing that we need to do is we need to get a 1 in the upper left-hand corner, and we've already got that. So then the next thing is directly below that 1, we need zeros. Okay, so I'm going to have to do something to row 2 and something to row 3. I need a new row 2 and a new row 3. Okay, well, to get the new row 2, let's take -2 times row 1 and then add those numbers to row 2. That'll make it so that this 2 turns into a 0. And then to get the new row 3, let's take -3 times row 1 plus row 3. That'll make it so that this 3 becomes a 0. Okay, so we're not doing anything to row 1. Row 1 is going to stay the same. Okay. Row 2, I'm taking -2 times row 1 plus row 2. So -2 times 1 is -2, plus 2 is 0. -2 times -1 is 2, plus 3 is 5. -2 times 1 is -2, plus -1, that's -3. And then -2 times 8 is -16, minus 2 is -18. Okay? And then to get the new row 3, we're taking -3 times row 1 plus row 3. Okay, so -3 times 1 is -3, plus 3 is 0. -3 times -1 is 3, plus -2, that's 1. -3 times 1 is -3, plus -9, that'd be -12. And then -3 times 8 is -24, plus 9 is -15. Column 1 is now done. Okay, and I'm going to move on to column 2. So the next thing is I need a 1 in the middle of the matrix. There's 2 ways that I can get that. The easiest method would be to switch rows 2 and 3. Okay, so that's what I did there to get the next matrix. Another method would be to multiply row 2 by 1/5. If you did that, though, you'd create fractions and try to avoid creating fractions here if possible. Okay, the answer is still going to be the same thing, but it's easier to work with numbers that are not in fractional form. Okay, so I switch row 2 and 3, and here's what I got. Now the next thing is this 5 needs to become a 0. So we need a new row 3. And to get row 3, we're going to take -5 times row 2 plus row 3. By the way, I have to use row 2 and row 3. I can't do anything with row 1. If I do anything with row 1 and then I add those numbers to row 3, then the 0 that I worked so hard to get is not going to be 0 anymore. And that's going to be a problem. Okay, so take -5 times row 2 plus row 3. Okay, 0 plus 0 is 0. -5 times 1 is -5, plus 5 is 0. -5 times -12 is 60, plus -3, that's 57. -5 times -15, that's 75. Minus 18, that would be 57. Okay, so here's the new matrix there. Now the next thing is I need this 57 to become a 1. So I'll need to do something to row 3 again. I need a new row 3. And let's take 1 over 57 times row 3. So 0 times anything is 0, right? 57 times 1 over 57, that's 1. And 57 times 1 over 57, that's 1. Okay, so now the matrix is in row echelon form, right? I got 1s down the diagonal and 0s in the lower triangular part, so now I can convert this back to a system. When I do that, I'll have x minus y plus z equals 8, and then y minus 12z equals negative 15, and then z is 1. Okay, so knowing that z is 1 means I can get y and then get x. We backtrack. So if z is 1, I got y minus 12 equals negative 15. When I add 12 to both sides, y is negative 3. And then with y being negative 3 and z being 1, I have x plus 3 plus, it should be plus 1, so x plus 4 equals 8. And if I subtract 4 from both sides, x is 4. Okay, so I think that the answer would be x is 4, y is negative 3, and z is 1. Let me check that. So is it true that 4 plus 3, that's 7, plus 1, that's 8? Yep, that's true. Is it also true that 8 minus 9, that's negative 1, and then minus 1, that's negative 2? Yeah. Okay, and is it also true that, let's see, 12 plus 6, that's 18, minus 9, that's 9. Yep, that looks good. Okay, so you can go ahead and circle that result there. X is 4, y is negative 3, and z is 1. Here's another example. So what if we want to solve this system? And well, let's create a matrix here. So here's the matrix. And good news, I've already got a 1 in the upper left-hand corner. That, again, is always step 1. So directly below this 1, I need this 2 to become a 0, and I need this 1 to become a 0. So I'm going to get a new row 2 and a new row 3. To get the new row 2, let's take negative 2 times row 1 plus row 2. To get the new row 3, let's take negative 1 times row 1 plus row 3. Okay, row 1 is going to stay the same. So I got 1, 1, 1, and 6. Row 2, I'm taking negative 2 times row 1 plus row 2. So negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 1 is negative 2, plus negative 1 is negative 3. Negative 2 times 1 is negative 2, plus negative 1, that's negative 3. Negative 2 times 6 is negative 12, plus 3 is negative 9. And then for row 3, we're taking negative row 1 plus row 3. Okay, so negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 plus 2 is 1. Negative 1 plus 2 is 1. And negative 6 plus 0 is negative 6. Okay, so here's where we're at now. Now the next thing is to get the, so column 1 is done, right? The next thing would be to get a 1 in the middle of the matrix. Let's go ahead and switch rows 2 and 3 to get that. So that's what I did here. Now I got the 1 in the middle of the matrix. Now directly below that 1, I'll need this negative 3 to become a 0. So I need a new row 3. Let's take 3 times row 2 plus row 3. Again, I can't do anything with row 1 because if I change this 0 here, then I'll get a wrong answer. Okay, so 3 times row 2 plus row 3, that'll get me the new row 3. 3 times 0 is 0, plus 0 is 0. Okay, 3 times 1 is 3, plus negative 3, that's 0. 3 times 1 is 3, plus negative 3, that's 0. And 3 times negative 6 is negative 18, plus negative 9, that's negative 27. Okay, now if I convert this back to a system, then the last equation would be where I'm saying 0 equals negative 27. Of course, that's not true. So I have an inconsistent system. Or there's no solutions to this system. Okay? Let's take a look at, I got one more example here. So what if I want to solve this system? Well, here's the matrix. Okay, so the first thing I need is a 1 in the upper left-hand corner. Right now it's a 6. There's two ways that I can get that to be a 1. One way is I can multiply row 1 by 1/6. Now if I do that, I'll create fractions right off the bat, and I don't like working with fractions. Okay, so there's an easier way to do this. If we take row 1 minus row 3 to get our new row 1, then that should do it. Okay, so check it out. We got 6 minus 5, that's 1. Negative 1 minus 1 is negative 2. Negative 1 plus 1 is 0. And then 4 minus 3, that's 1. Everything else is going to stay the same as it was. Okay, so this is the matrix that I've got right now. And now directly below that 1, I need this negative 12 to be a 0, and I need this 5 to be a 0. So I'm going to get a new row 2 and a new row 3. To get the new row 2, let's take 12 times row 1, and then add those numbers to row 2. To get the new row 3, let's take negative 5 times row 1, and then we'll add those numbers to row 3. So row 1 is going to stay the same, as I got it there. And row 2, I'm taking 12 times row 1 plus row 2. Okay, so 12 times 1 is 12, plus negative 12, that's 0. 12 times negative 2 is negative 24, plus 2, that'd be negative 22. 12 times 0 is 0, plus 2 is 2. And 12 times 1 is 12, plus negative 8 is 4. Okay? And then to get the new row 3, I'm taking negative 5 times row 1 plus row 3. Okay, so let's do that. Negative 5 times 1 is negative 5, plus 5 is 0. Negative 5 times negative 2 is 10, plus 1 is 11. Negative 5 times 0 is 0, plus negative 1 is negative 1. And then negative 5 times 1 is negative 5, plus 3 is negative 2. Okay, so here's where I'm at right now. So then the next thing is I need a 1 in the middle of the matrix. Well, to get that, I guess I could multiply row 2 by negative 1 over 22. That again, that'd be my only option actually. I can't get a 1 in the middle of the matrix any other way. So that's what I do next, and I'm creating fractions. Okay, so rows 1 and 3 are going to stay the same. In row 2, I'm multiplying all these numbers here by negative 1 over 22. 0 times anything is 0, right? Negative 22 times negative 1 over 22, that'd be 1. Negative 1 over 22 times 2 would be negative 2 over 22. That reduces to negative 1 over 11. And negative 1 over 22 times 4, that would be negative 4 over 22. That reduces to negative 2 over 11. Okay, so now we've got the 1 in the middle of the matrix. That looks good. Directly below that 1, I need this 11 to be a 0. Okay, so let's go ahead and do that. We need a new row 3. To get the new row 3, we'll take negative 11 times row 2 plus row 3. Okay, Rows 1 and 2 are going to stay the same there. So we're getting a new row 3. Negative 11 times row 2 plus row 3. Okay, so negative 11 times 0 is 0 plus 0 is 0. Negative 11 times 1 is negative 11 plus 11, that'd be 0. Negative 11 times negative 1/11 would be 1 plus negative 1, that's 0. And then negative 11 times negative 2/11 is 2 plus negative 2 is 0. Okay, now if we convert this back to a system here, the last equation we're saying 0 equals 0. Well, that's true, right? 0 equals 0. And so I've got a dependent system. Okay, my answer always has to be written as an ordered triplet here, either in terms of x or y or z. I'm writing the answer in terms of z. So let's see. So I got x, y, z. I need to get y in terms of z. Well, so here's the system that I would get at this point. I've got x minus 2y equals 1, and then y minus 1/11 z equals negative 2/11. So if I solve this equation for y is equal to 1/11 z minus 2/11. That's going to go right there. And then to get the x coordinate, x minus 2y equals 1. Well, I know what y is. I just found that, right? So x minus 2 times y is 1/11 z minus 2/11 equals 1. Okay, so x minus 2/11 z plus 4/11 equals 1. If we subtract 4/11, 1 minus 4/11 is 7/11. And if I add 2/11 z to both sides, x is equal to 2/11 z plus 7/11. Okay, and I go ahead and write that expression there in the x coordinate spot. So my answer would be 2/11 z plus 7/11, 1/11 z minus 2/11, and z. Okay, and we're saying that there's infinitely many solutions to that system. So if you give me a number, whatever number you give me, z, I can always find the x and y values. Okay, again, the point is that you can give me any number, though, to get started with the problem. So there's going to be infinitely many choices there. There'll be infinitely many answers that you can say. Okay. All right. So that is it for the course. The last homework is on page 412 there, so be sure to look at those problems when you get a chance.